Hi friends, let us discuss 1's complement and 2's complement of binary number in GATE lecture series. Let us see what is 1's complement and 2's complement of binary number. First, let us try to understand what is 1's complement. The 1's complement of a binary number is calculated by inverting each bit. That means the ones complement of 1010 is we invert each bit. That means zeros will become ones and ones will become zeros. So this 0 will become 1 and this 1 will become 0 and this 0 will become 1 and this 1 will become 0. So the ones complement of 1010 is 0101. Next, we see what is 2's complement. To get 2's complement of a binary number, invert the each bit and add 1 to the least significant bit. That means to get 2's complement of a binary number, find the 1's complement of the number, then you add 1 to the least significant bit. For example, you take 2's complement of 1010. So we know what is the 1's complement of 1010. That is 0101. Now you add 1 to the least significant bit of this number. So you can see that how we add. So 1's complement of 1010 is 0101. You add 1 to the least significant bit. So when you add 1 plus 1, you'll get 1 0. So you put 0 here and the 1 will be carried to the this bit. So 0 plus 1, 1. This 1 will be carried out as it is and this 0 will be carried out as it is. So the 2's complement of 1010 is 0110. Let us see 1's complement subtraction. A minus B. A is a binary number and B also a binary number. First, let us try to answer a question. Why we use complement arithmetic for subtraction of binary numbers? The main reason is it minimizes the hardware implementation for subtraction operation in a computer. So, it is better to use complement arithmetic for subtraction of binary numbers. Still, 2's complement subtraction will be better than 1's complement subtraction for subtraction of binary numbers. Anyway, let us see how 1's complement subtraction is done. So, for example, A and B be the binary numbers with the same number of digits. That is, number of digits will be same. That is 3 digit means another number will also have 3 digits. Otherwise, you add extra 0 at the beginning. Suppose if one number is having lesser number of digits, you add the zeros in the beginning so that it will not affect the value of the number. Then calculate 1's complement of B. Then you add result of step 2 with A. If there is extra bit, remove that extra bit and add on in its remaining bit. If there is no extra bit, find 1's complement of result in step 3 and add a negative sign. So these are the steps to be carried out for subtraction of two binary numbers. So let us see the example for this. For example, you take A is equal to 1101 and B is equal to 1010. So you take 1's complement of B, isn't it? So 1's complement of B is, so you know how to calculate the 1's complement. So invert each bit. So you get 0101. Now you add these two numbers. So when you add these two numbers, 1 plus 1 it will become 10. So you put 0 here, 1 will be carried out this bit. So here other bits are 0, so you just put 1. So now you add 1 plus 1, it will become 10. So 0 you keep it here and 1 will go to this place. So if you add 1 plus this 1, so again it will become 10. So the final result is like this. So you see the steps. So if there is extra bit, so there is a extra bit here. So remove that extra bit and add on in its remaining bit. So you go to this place, so extra bit 1 is there, so you add with the remaining result. That means that extra bit should be added to the least significant bit of this result. So you add here, so you'll get the result 0011.
Decimal value of this binary number A is 13. Decimal value of this binary number B is 10. The decimal value of the result is 3. That is 13 minus 10 is equal to 3. Let us take another example. Binary number A 1 1 and binary number B 1 1 1. We want to find A minus B. We have already discussed that both the binary numbers should have same number of digits. So we add 0 at the beginning in A to make same number of digits in both A and B. So after adding 0 in A, so A is 0 1 1 and B is 1 1 1. Now we want to find the A minus B using 1's complement subtraction method. So you find the 1's complement of B. 1's complement of B, that is invert all the ones to zeros and zeros to ones, but B is having only 3 ones, so you make it as all ones as 0. So 1's complement of B is 0 0 0. So now add A with B. So when you add A with B, 1 plus 0 1, 1 plus 0 1 and 0 plus 0 0. So this is the result of this addition of A and B. Now based on the result, what we are going to do, there is no extra bit, so find 1's complement of the result, then add negative sign. This rule we have already discussed in 1's complement subtraction method. So you have to find the 1's complement of this result. So that means this will become 1 0 0 and we have to add the negative sign. So you can see that the decimal value of A is 3, decimal value of B is 7 and decimal value of result is minus 4. That means 3 minus 7 minus 4. Let us take another example. Binary number A 1010, binary number B 1011. We have to find A minus B. So now we have to find the 1's complement of B. So what is the 1's complement of B? 0 1 0 0. Now we have to add A with B. So now we add A is 1010 and 1's complement of B is 0 1 0 0. So you add these two. So the result is 1 1 1 0. So as there is no extra bit, so what we have to do, find 1's complement of the result, then add negative sign. So 1's complement of this result is 0 0 0 1. So you add minus sign here. So what is the decimal value of A? 10. Decimal value of B is 11 and decimal value of result is minus 1. That is 10 minus 11 minus 1. Listen carefully. We write A minus B is equal to A plus minus B. Then what we do, we find the 1's complement of this B and we follow the procedure for 1's complement subtraction. That is what we have done in previous cases. Now let us see something about binary bit representation of a number. Suppose you assume 8 bits for a number and in the previous cases we have assumed positive number or otherwise we call it as unsigned integer. What does it mean? If there are 8 bits are reserved for the particular number, all the 8 bits are used for magnitude. That means this all the 8 bits represent the number. For example, this uh, collection or combination of bits represent the value 146 in decimal. But when we talk about signed integer, the difference is the first bit always reserved for sign. That means 1 in this place represent negative number 0 in this place represent positive number. So what happens here? The remaining 7 bits are used for magnitude, and first bit always reserved for storing the sign of the number. That is the case of signed integer. So for the signed integer, the decimal value will be minus 18. Now let us perform minus 2 minus 3 in 1's complement form. This can be written as minus 2 plus 3, because this minus into minus it will become plus. Assume 6 bits are used to represent the signed integer here. Then minus 2 will be represented like this. That is, first bit 1 indicates it is a negative value, and the remaining magnitude represents the 2. And plus 3 will be represented like this. That is, first bit 0 indicates that this is a positive number, and the remaining bits represent the magnitude 3. Now find 1's complement of the negative number minus 2. What we should observe here is we should consider only the magnitude. So you forget about the sign bit in both the values. So you take only the remaining 5 bits and find the 1's complement. So the remaining 5 bits, if you find the 1's complement, it will become 11101. So now you add this with this plus 3 value. So that is, you add it here. So 1 plus 1, it will become in binary 1 0. That means 0 will come here, 1 will be taken as a carry. So again, if you put 1 plus 1, again 1 0, again 0 will be displayed here, and 1 will become carry. So again 1 plus 1, 0, again 1 will be a carry. So again you add it here, 1 plus 1, 1 0. So 0 will be stored here, and 1 will be a carry. So again 1 plus 1, 1 0. So 0 will come here, and 1 will be stored here. So as per the rule, there is a extra bit. So if there is a extra bit, you add with the remaining result. So this extra bit should be add with the remaining result. So what will you get? You will get this result when you add this one with this remaining result. So now what is the result in decimal? Minus 2 plus 3 will become 1. So that is what we got it in binary also. Now let us see the procedure for 2's complement subtraction, that is a minus b using 2's complement subtraction method. A and b be the binary numbers with same number of digits. So that is the rule. Otherwise, add 0 at the beginning to make it both a and b has the same number of digits. Next step, calculate 2's complement of b. Third step, add the result of step 2 with a. If there is extra bit, remove that extra bit, and remaining will be the answer. If there is no extra bit, find 2's complement of the result in step 3 and add negative sign. So this is the procedure for 2's complement subtraction. So let us see example here. So you take a binary number A 1001 and B is 1000. So we find the 2's complement of B. So when you want to find the 2's complement of B, we should find first 1's complement. So 1's complement of B is 0111. Then you add 1 to the 1's complement of B. So if you add 1 with this 1's complement of B, you will get the result 1000. So now we have calculated 2's complement of B. So now what we have to do? We have to add the result with a. So 2's complement is 1000. You add 1000 with a 1001. So you add it here. So 0 plus 1 1, and 0 plus 0 0, and 0 plus 0 0. But when you add 1 plus 1 in binary, you get 10. So this is the result of this addition. So now there is a extra bit, isn't it or not? So you remove that and the answer is the remaining bits, that is 0, 0, 0, 1. So now we see the what is the decimal value of this binary number A. Decimal value of this binary number is actually 9, and decimal value of this B is 8. So 9 minus 8 you get 1. Let us take another example. Binary number A 0, 1, 0, 0. Binary number B 1, 0, 0, 0. So first let us find the 2's complement of B, because we want to find A minus B. So we will find the 2's complement of B. So for that we find the 1's complement of B, that is 0, 1, 1, 1, and add 1 to this 1's complement. So you will get 1, 0, 0, 0. So now what we have to do? We have to add this 2's complement of B with A. So when you do that, you get the result 0 plus 0, 0, 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1. So now there is no extra bit. So as per the rule, we find the 2's complement of the result. So this is the result. So we have to find the 2's complement. So let us find the 1's complement for that. So 1's complement of this result is 0, 0, 1, 1, and add 1 to the above, you will get 0, 1, 0, 0. Now as per the rule, you add the negative sign to the result. So the decimal value of this binary number A is 4, and decimal value of this binary number B is 8. 4 minus 8 you will get minus 4. So that is what you got it here. The decimal value of this result is minus 4. Now let us perform minus 2 minus minus 3 in 2's complement form. This can be written as minus 2 plus 3, because this minus into minus will become plus. Now we take the form of signed integer. So if we take a 6-bit for each number, then minus 2 will be represented like this. That is, first bit 1 indicates this is a negative number, and the remaining 5 bits represent the magnitude 2. And plus 3 is represented like this. The first bit 0 indicates this is a positive number, and the remaining 5 bits represent the magnitude 3. Now we have to find the 2's complement of the negative number minus 2. But you should remember that when you do the process of 2's complement subtraction, you forget about the sign bit. That means you leave the sign bit and find the 2's complement of the remaining magnitude. So to find the 2's complement, we should find the 1's complement. So you take the magnitude of this number, then find the 1's complement, that is 1, 1, 1, 0, 1. For finding the 2's complement, we have to add 1 to this number. So when you add 1 to this number, you will get this result, that is 1, 1, 1, 1, 0. So how did we get it? By adding 1 with this 1's complement. Now we have to add the 2's complement of this negative number with the another value, that is 3 here. You just add it here, 0 plus 1, 1, and 1 plus 1, as we already discussed, this will become 1, 0. So you put 0 here, 1 will be taken as a carry. Again 1 plus 1, 0, 1, 0. So 0 will be stored here, and 1 will become carry. Then 1 plus 1, again 1, 0. So you put 0 here, again 1 will become carry. So when you add 1 plus 1, you will get 1, 0 here. Now we find the extra bit. So as we find the extra bit 1, remove that, and the remaining is the result. So the extra bit is removed. So the remaining is the result. So what is the result of minus 2 plus 3? 1. So that is what we got it in binary also.